Good afternoon, I am Mr. Ish. Thank you for joining me. It's not a bad idea, and it would be prudent to look very quickly at this concept of arithmetic progression, which you can say synonymously as arithmetic series and or sequence if you use the terms very loosely. What is an arithmetic progression? Consider this. You have 10, 20, 30, 40, and onwards. When you're looking at this, you see that there's a sequence here of numbers which are with regards to each other in a common difference. From here to here, here to here, here to here, you see a common difference. The common difference is always your number after minus a number before, and here the difference is 10. You have a term which is the first term, a1, which is 10. An arithmetic progression has what is called a common difference, whereas what you know now, geometric progressions have a common ratio. Common difference is a defining feature of arithmetic sequence or arithmetic series, and we should look at this with regards to just a general two formulas you should know. The nth number of an arithmetic progression and the sum of the numbers up to that nth number. What are they? The nth number is always, in terms of a formula, a1 plus n minus 1 times d. The number you're looking at, less 1 times your common difference plus your first number of that sequence. This right here, the sum of the numbers in that sequence up to your interested value, is equal to n over 2 times a1 plus an. How would you relate these with regards to an actual example? It's just so we can develop some confidence and some meaning in this. Well, let's look at this series right here. 3, 5, 7, 9 and onwards. What's the first term over here? And you know this is a very easy and intuitive series to understand. It's an arithmetic series because you have a common difference show up. Your first term here is a 3. Your common difference is always 2. Each number is 2 more than the one right before it. If I were to be tasked with finding the 19th term, you can do counting, manual counting, but it would take time, or you can utilize this formula. You do your first term plus n minus 1. This right here is your nth value, 19 minus 1 times your common difference, 2, and you get a value. And we'll bring out a calculator and calculate this. 19 minus 1 times 2 plus 3. The 19th term of this sequence, arithmetic sequence, would be 39. And now what would be the sum of these 19 numbers? Well, you'd look at this formula. You do 19 over 2 times your first number, 3, but you would have had to determine this, so you could plug it right here, which is 39, and you'd run this through on your calculator and you'd have a good value. 3 plus 39 divided by 2 times 19, and your answer would be 399. Both of these answers would be good, and it's a very easy formula, or two formulas to know. This one right over here and then this one right over here. These are your arithmetic progression determination formulas. Given these formulas in mind, now let's increase the difficulty here of this next question and make it quite interesting in terms of a puzzle-like question, and then that should be it for this particular video. Now this right here is not a very straightforward question because you have to kind of work backwards, and it'll involve multiple different skills to solve it. You're given the 17th term, which is minus 8. You're given the third term, which is 34. We have to find the series, what is the arithmetic progression, or get a rough idea of that progression, and we have to find the sum of the first 20 terms. How would you go about doing this? You're given an values. We have an in terms of a formula as a1 plus n minus 1 times d. We're given two separate instances of these an values. We have a17 and we have a3. This would come first in terms of the series because this is the third value. This would come second. So we can use these values here and come up with something. With regards to the A3, which is provided, we have a 34. That 34 represents your actual an value, is equal to a1 plus n minus 1. What is n? N right here would be 3. 3 minus 1 times d. We don't know what d is. We have to find that out. With regards to the 17th value which you provided, you have actual value minus 8 is equal to a1 plus, you have a 17 over here, 17 minus 1 times d. Convert these into simplified expressions. You have 34 is equal to a1 plus 2d. Here you have a minus 8 is equal to a1 plus 16d. Now what does this look like, all of this? It looks like a system of linear equations. You can do elimination over here and actually solve for d. If I were to minus the second one from the first, what would I get? I'd get a 34 minus 8. It would be a 42. is equal to, these a's would cancel out, then I'll have a 2 minus 16d, it'll be a minus 14d, and then d here is equal to 42 divided by minus 14, which is minus 3. And now all of a sudden I've determined the common difference. The common difference is d. Just plug that d value into any of these and you'll calculate your first value, which is your a1. I'll put d right over here. I have 34 is equal to a1 plus 2 times minus 3, which is minus 6. a1 is equal to 34 plus 6, it'll be 40. You can do the same thing in the second equation and you'll still get 40. So now I've determined my first term is equal to 40. Now that I've determined the first term and I know the common difference, I can easily calculate this and I can easily determine that. It would be prudent now to actually calculate this. I brought the common difference here, I brought the first value over here, but to actually calculate the S20, because you know the Sn formula for an arithmetic progression is always n over 2 times a1 plus an, I'd need to still find this. I'll have to find what a20 value is, and that would be easy because I know my first value and I know my common difference. It would be 40 plus n minus 1, which is 20 minus 1 times your common difference minus 3. When you do this, you'll get your a20th value, and then we can easily determine the sum of those 20 values of that progression. We'd have 19 times 3 minus plus 40. I'm getting here an a20 value of a minus 17. So a20 is equal to minus 17. Now we have everything in play to determine the sum of the first 20 items of this progression. What I've done is make a little space. So let's do S20. What is S20? It's going to be 20 divided by 2 times your first term, which is 40 plus minus 17. Run this through on your calculator and you get the sum of the first 20 items of this progression. 40 minus 17 divided by 2, multiply that by 20 and you get 230, and that answer would be right, 230. So Sn or S20 is equal to 230, and that answer should be right. Now let's look at this right here, the arithmetic progression. We don't have to write it all out, but what we can do is start giving an idea or an indication of what it would be, and let's lay it out for you over here. The progression is by no means out of this world. It starts here by 40 and it has a common difference of minus 3, so the next one would be 37, then the next one would be 34, and then the next one would be 31, and then 31 minus 3, you'll have a 28, you'll have a 25, you'll have a 22, and then you'll have a 19. Now look, this is what the series is looking like. If you went to the 20th term, you'd end up at minus 17. We're just at 1, 2, 3, 4, 5, 6, 7, 8. We're here at just the a8th term. Well, we also know the a3rd term was 34, which is right here, my a3rd term, so we're good. If you went to the 17th term, it should be minus 8, and again the 20th term will be minus 17. If you were to add these up to the 20th term, you'll have 230. But this right here was all I wanted to show you here with regards to this beginners or basic introduction to arithmetic progression, something you should know, and the formulas which you should know were the ones which were related to an, and the other one was related to Sn, is always n over 2 times your first plus your nth item. And that's the formula you need to be aware of. And that's it. Thank you for watching. Have a good day.